Right. Good morning, everyone. I'm Parvis Khansari, and I'll be chairing today's seminar. I'd like to welcome all the delegates participating in this morning's session. We've got a great mix of people attending from across the highway sector, and I hope you all enjoy this seminar. We will be recording the event, and this will be available to all delegates afterwards. The event will be replayed on Hopin at 6:30 this evening. This is the second in a series of 3 webinars. In the first event, Decarbonising the Highway Sector, we learned about how the next 10 years are crucial to achieving ambitious targets to cut carbon emissions and how carbon management knowledge needs to be rapidly embedded across organizations. I believe we also learned that the fog may be replacing the cloud very soon. During the event, we ran a quick poll asking how far carbon reduction had been embedded in people's workplaces. The poll showed us that 57% of respondents said that it has been a little, and 43% said it has been embedded a lot. In 2019, 13 of 14 local authorities who are members of Southwest Highways Alliance declared a climate emergency, with all the member authorities setting ambitious targets for carbon reduction. Our program board was keen to set up a work program around the topic of decarbonisation, prompting the call for a second conference exploring this topic. Originally, it was supposed to be held as a conference last year, but of course we all know COVID happened and it was postponed twice, and now it's running as 3 webinars. I'd like to give a big thanks to our sponsor Atkins for continuing to support the event in its virtual form. The next session, by the way, will be on the 22nd of June, and a link will appear in the chat box and will tell you how to join in. We've got a great selection of speakers taking part in today's session, covering a diverse range of topics within the overall theme of decarbonising the highway sector. We'll be starting with presentations from Mike Sudden from Eurobitume, Teddy Taleongpong, who will be talking about estimating lifecycle carbon in highways works. Brian Kent will then talk about reducing carbon with recycled roads. We'll then have a question and answer session. There will also be time to put a kettle on and have a break as well. Please, at all times, put whatever questions you've got in the QA box, and we will go through them later on. After the interlude, we're going to have Victoria Walsh talking about CO2 net zero in highways construction. Then Ollie Beach will be talking about low carbon highways maintenance. We'll have after that Lucia de Ferraris talking about graphene trials in highways. Chris Ball will be talking about going digital, which is not just about getting rid of paper. And finally, Paul Aldridge will have a case study on road markings carbon calculator. After that, we'll have a short question and answer session at the end as well. So please keep putting your questions in, and we'll go through them at the end. So without further to say, I shall hand over to Mike. Thank you.
Thanks very much, Parvis. If I click on the right button, are you seeing my intro slide?
Yes, we are, Mike.
Okay, perfect. Thanks for that. Okay, so thank you for the introduction. My name is Mike Southern. I'm a Senior Technical Advisor with Eurobitume, which is the European Bitumen Association. We like to consider ourselves as the voice for the bitumen and associated industries with bitumen. It's based in Brussels. I'm based in the UK, and I haven't been to Brussels for 18 months now. So well, we all know why that is. Today, I'm going to talk a little bit about environmental impact assessment, why we are interested in assessing the environment and how we do it, and what Eurobitume is doing to assist that process. I also like to talk a little bit about the complexity and the regulatory drivers for that. It is, we all would like to do the right thing in our personal and our occupational lives. It's not really very simple, and what I'm discovering is the closer you get to it, the more complex it becomes. And I'm just going to touch on some of those areas throughout the presentation. So let's start talking about the regulatory framework. At the moment, the UK, despite leaving the European Union, is still subject to the regulatory framework in general. But across Europe, the driver for this and other standards in bitumen is the construction products regulation. And within the CPR, there are a number of basic work requirements established, and these work requirements have to be incorporated into the standardization process, so the standards that we use. Those cover the obvious stuff, such as mechanical resistance and stability, safety in case of fire, hygiene, health, environment, and are generally written to cover vertical structures as well as horizontal structures. So there's a couple in pale grey about protection against noise, energy economy, and heat retention. But there's this final seventh requirement, which is sustainable use of natural resources. And as and when our harmonized standards for construction products come up for renewal, they are going to be required to address sustainable use of natural resources. And these take into account recyclability and environmentally compatible raw and secondary materials within the construction works. And these basic work requirements must be incorporated into the standards. In addition to that, roads are typically owned by public bodies and paid for using public money. Across Europe, the public authorities are major consumers. I don't think anybody would question that as far as road pavements are concerned. And the public authorities are required to follow public procurement criteria when they purchase materials. And subsequently, the Commission has drawn up green public procurement criteria. And I can strongly recommend that if anybody's having difficulty sleeping, you can go to the Europa website and you can download these green public procurement criteria, because there's hundreds of pages of text on how public agencies can incorporate green criteria into their tender documents. At the moment, they're a voluntary instrument, which means the member states and public agencies can determine which of the criteria they incorporate into their bids. They're not obliged to do so at this stage, but the criteria are developed to help the inclusion of green requirements. And we're talking about carbon, but environmental impact is much more than just carbon. And there are many other criteria that authorities can choose depending on their ambition levels. And certain EU member states are already moving down that path and actually incorporating GPP criteria into their bid process. Like any other aspect of our industry, we've got a whole bunch of acronyms which we use. And I'm just going to start wading through a few of those. So environmental product declarations, or EPDs, are a bit like the nutrition label that you might see on the side of your packet of cornflakes. And they will inform users of a particular construction product about the various environmental impacts. And to draw up an EPD, you've got to have a rule book. And on the right-hand side of the screen, you'll see a European norm, which talks about developing the product category rules. So when you're playing any kind of game, you have to have common rules so that everybody understands what we're doing and how we're doing it. And these are product category rules for the construction industry and construction products used by that industry. It establishes the playing field to enable us to evaluate the environmental impact of the construction products that we're using. And if you'd like to compare one construction product with another, it's important that we do so on a common basis. And the EPD is the common basis that we're going to use across Europe for construction products at the moment. We talk about life cycle, generally speaking. And when we talk about life cycle, then we've got to look at the whole life of a construction product. And within an environmental product declaration, what I've put on the screen now is looking at the various life cycle stages of a construction material. So if we take an asphalt mixture, for example, then we need certain raw materials. And on the far left, we can see that for an asphalt pavement, we would have asphalt as a mixture, which will have some raw materials. So bitumen, aggregate, sand and filler, and maybe some other additives, and they are raw materials. And so we need to understand what the environmental impact of those is. They need to be transported to the coating plant. The material itself needs to be manufactured, and then that material is transported to the work site and installed in the work site. And so section A of an EPD it talks about the product and the construction process stage. Thereafter, we have an asphalt pavement and it's being used, and during its life, it will need to be maintained, repaired, perhaps replaced or refurbished. And for things like street lighting, for example, there could be operational energy use, and there could be operational water use as well, or other material use. And then at the end of the life, that material needs to be deconstructed. The waste material needs to be transported and processed and either disposed of or reused, recycled, recovered, etc., etc. So that is when we're talking about assessing the life cycle impact of a product, we need a tool with which to do it. And currently the tool we're talking about is an environmental product declaration, or EPD. Another couple of acronyms here that you may have heard of, and that's an LCI, or a life cycle inventory, or an LCA, a life cycle assessment, or a life cycle impact assessment sometimes. And these are clearly related, but they're different things. So I'm going to talk first about a life cycle inventory. As the name suggests, it's a list of flows into a system and out from that system. So we look at the resource consumption in terms of air, water, and soil. That material extraction and processing will have impacts on and emissions to the air, water, and soil. And a life cycle inventory, and I'll show you an example of one of those in a minute, is an extremely long list of flows from and to the environment. And the LCI itself is a necessary first step in assessing a life cycle impact overall, but you'll see in a couple of slides' time that an LCI is about 4,000 lines of flow chart, and it's not very usable in itself. So all of those inventories are compiled into a general set of indicators which will show an impact on the environment in terms of global warming potential, resource depletion, and acidification potential, and so on and so on. So LCA, LCI, EPD, PCR, we've got a good number of acronyms already. And Eurobitume has prepared a life cycle inventory for bitumen. And that LCI is based upon a hypothetical refinery based somewhere in Northwest Europe, running an average diet of crude, typically crudes which are used for bitumen production. And when we talk about assessing an impact, we need to understand the unit that we're talking about. And so for us, it's 1 ton of a paving bitumen complying with a British standard EN 12591, and then as you move through an EPD, we might look at a ton of asphalt mix, and then when that asphalt mix becomes a road, we might look at a square meter of road pavement. So we've got to talk about declared or functional units as well, so that we know if we're going to compare one thing with another, exactly what we're talking about. So the LCI for bitumen is what we call a cradle to gate study, and we start counting at the crude oil extraction stage. That crude oil needs to be transported to the refinery in Europe, and then it's manufactured and it's stored in storage tanks. And that is as far as we go with our LCI, because going back to the EPD, we are a raw material, and the next stage of its life would be transportation to an asphalt mixing plant or a roofing membrane production plant, and that would move into the next stage of an EPD. So just to highlight that whenever we're talking about environmental impact assessment, we need to understand where we start and where we stop so that we count correctly. A couple of additional buzzwords when we're talking about environmental impact assessment: system boundaries, so where we start, where we stop, and if we're going to compare one LCI or an LCA with another, then we need to make sure that that system is defined correctly and that we're not overlapping. And the problem is that despite having a European norm setting out some basic rules or product category rules, we don't have a well-established playing field yet. It's still a little bit the Wild West out there. So when we've got that, we need to be very, very clear when we're counting that we're counting on the same basis. The second buzzwords are allocation methodologies. So oil refineries are complicated places. An oil refinery takes in a variety of crude oils and it spits out a whole variety of materials. And somehow we've got to decide how we're going to allocate the resource consumption and the emissions from the refinery across the suite of materials. So understanding how to allocate material use and resource use is quite important. So we use the allocation methodology to partition environmental loads. And we've got to make sure when we do that that we don't count the same thing twice, so that if we're taking some environmental burden, we need to make sure that nobody else takes that, or that we don't conveniently forget something. So we've got to make sure that we understand the system boundaries. I mentioned that we've done an LCI. This is an example of an LCI. Don't try and read it because it goes on for row after row after row, and we can see that this one is just a couple of lines short of 4,000 lines of environmental impact assessment, which is an awful lot to try and deal with in terms of assessing environmental impact. So we simplify that into an environmental impact assessment, an LCIA, life cycle impact assessment. And you can see that at that stage, we've simplified it down into, in this case, half a dozen different climate indications. We've talked about carbon a little bit. So we look at climate change, global warming potential, But there are other environmental impact indicators. So we've got ozone depletion, acidification, resource use, and so on. And we can split that down into the 4 life cycle stages of the LCI. So crude oil production, the transportation, the refining, and the storage. So an LCIA or an LCA is a convenient method of summarizing those 4,000 lines. This is just a bit of flag waving for our own. We've got a Eurobitume LCI. Other databases are available, and you can see a couple of examples of those on the screen. So why use ours? We believe we've got the most reliable. So we use data from the Oil and Gas Producers Association for crude oil extraction. We use actual ship data for transportation, and we use the European Refining Association for refinery fuel mix and so on. But we spit out those 4,000 lines of LCI in a format which sustainability professionals can use in proprietary LCI software, for example, SEMA Pro. Zooming in a little bit on carbon, PIARC, the World Road Association, has produced a couple of reports which you might find interesting on reducing the life cycle carbon footprint of pavements and green paving solutions. Both of these reports are freely available on the PIARC website. And they—
1 minute to wrap up, please. Thank you.
Yeah, 3 slides. So the environmental product declarations, they show the various life cycle stages, and I mentioned that assessment is quite complicated, and when you look at a range of different models, and I've got a few examples of those. You might be familiar in the UK with Aspect, which is a carbon calculator. There are other models available, and the nationalities of those models are shown on the left-hand stage. They include different stages of the life cycle. So when you put the same information into each of these models, you very often get a different number out. And one of the reasons for that is that they're covering different life cycle stages. And this is one of the points that I made about system boundaries and understanding, where you're going to start counting and where you're going to stop counting, because it can be quite confusing for users to understand, well, why do I get a different number from Aspect as I do from SEV or ECA or one of the other models? So please go and have a look at the PIARC reports, and I'd be pleased also to give you a little bit of information on how we use and how we generate the data within our LCI. Just to wrap up, hopefully it's clear that sustainability assessment is complex. It's not all about carbon. There are other aspects to consider. It's important to look at the whole picture, so not just what the impact of the raw materials is, not just what the impact of the construction product itself is, but its part in the whole life cycle of a road pavement. The construction products are only one small part of the equation. We don't just build roads because we like to have a nice road pavement. We build them for the traffic to use, and the influence of the pavement on the traffic fuel consumption and rideability is also important. And it is important to have smooth, well-maintained pavements to reduce the actual life cycle impact of the highway on the vehicles which are using it. And with that one, we'll stop there.
Very much, Mike, for that interesting talk. We'll come back to your questions at the end, if we may. So I'd like to move on to Teddy, who's going to talk about estimating life cycle carbon in highways as well. Teddy, if you can keep your camera on, that would be helpful. Very much.
Hello, everyone. Let me share my presentation. I apologize in advance for any background noise. Like everyone else, I'm working from home, and our neighbors are doing some construction work themselves. So I can't really do anything about that. But I'll try and talk clearly and concisely to get the message through. So just to introduce our company here, we're Metis consultants. We're founded in 2009, so we're relatively young. We focus on two main sectors: the highway and infrastructure sector and the water environment sector. And I myself am in the asset management team and lead on all carbon-related projects. Our initial experience with respect to carbon is in 2019, where we developed a tool for Westminster City Council to help them evaluate the carbon of their construction schemes. However, our experience and expertise, as well as the tool and the service itself, has improved exponentially as we worked with more local authorities to help them understand the carbon of their highway schemes. And we're all aware of the climate crisis. Most local authorities have declared a climate emergency. And with this pandemic, the central government's been pushing for a greener return to normal life. So with this in mind, we developed a service building on the good work of the EPDs developed by organizations such as Eurobitume from Mike's presentation to help with decision making within the highways industry. So in this presentation, I'll go through generally what our carbon assessment service considers, an example of a simple decision that can be made. We'll also go through some outputs from a project that we worked with South Gloucestershire to understand the carbon of their public realm schemes and the decisions that can be made in that case. So first of all, let's try to quantify the problem. What are we actually trying to solve? In this case, we're trying to quantify the benefits and disbenefits of various decisions regarding the environmental impact and the cost. So if we look at two very simple variables, the carbon and the monetary cost of certain materials, we can expect a more expensive product or material to have a lower carbon because of research and development, etc. But in the market, there may be products with that are cheaper and have low carbon, but also products that are more expensive and have high carbon. But as Mike explained previously in his presentation, there are many factors that need to be considered when we calculate carbon, and the problem's not that simple. So we have to look at things like transportation. A cheaper product may not be so, and low carbon product may not be so impressive if it has to be shipped from the other side of the world, and equally a more expensive product may be produced within the country, which may aid decision. Other factors that need to be considered are things like expected life. A cheaper product may only last 5 years compared to 30 years. And the mode of transport, this will incur different carbon amounts. The construction activity itself, so how schemes are constructed, what plants are used, and how long they're used for will impact the carbon of the scheme. Also the maintenance, so how are we replacing the assets, or are we doing nothing to it? And also things like the carbon cost, which is a rate set by the UK government. With these variables in mind, what our service aims to do is to help our clients comprehend the carbon of their construction schemes, build different options, compare the metrics of the different options, and make certain decisions with that information. So in terms of the framework itself, we have 3 different stages that we consider. The first stage being the 4U stage. Now that includes the raw material extraction, the manufacturing, transportation, construction, and the monetary costs incurred in that stage. The U stage, which looks at the operation and maintenance and the costs associated with that stage, and the end of life stage, which looks at the different means of disposal. So things like reusing, storing off-site, or sending a product to a licensed tip, the transportation, and the monetary costs incurred in these stages. Now, this aligns with the International Standard for Managing Infrastructure Carbon, PAS 2080. Again, same diagram as shown in the previous presentation. So if we move on to a very quick example, very simple example, 1,000 meters squared of granite, let's see how we can make a very simple decision by estimating the carbon of this scheme. So first of all, let's look at the before use stage. If we look at 1,000 meters squared of granite and the embodied carbon of the material is approximately 0.23 tons per meter squared, this means that the total product carbon of 1,000 meters squared is 230 tons of carbon, and the total cost is about £100,000. Staying at the before use stage, looking at transportation, here are the different main sources of granite throughout the world, with the extremes being China and Spain in terms of the transportation carbon emissions. So from China, 1,000 meters squared of granite transported from there to the UK will incur about 95 tons of carbon dioxide equivalent, and 1,000 meters squared from Spain will incur about 15 tons of carbon dioxide equivalent. Moving on to the use stage, if we want to maintain this scheme, and let's say we want to replace the granite, so we have an expected life of granite of about 40 years, and we want to replace 25 meters squared per year, so that by the end of the 40-year life, we end up with a maintained state of granite. How much carbon would this incur? This would incur 5.75 tons of carbon dioxide equivalent each year in terms of the materials. And in terms of the transportation, if we transport this 25 meters squared per year from China every year, this will incur 2.4 tons of carbon dioxide equivalent per year. And in terms of the maintenance costs, this will be about £2,500 each year. And just to note here, we're only looking at the material embodied carbon and the transportation to make this simple decision. Onto the end of life stage. Generally, within highways, there are 3 items in the schedule of rates associated with disposal. These will have different carbon amounts and costs incurred, whereby the carbon for each of these items are associated with the process of deconstruction and the transportation to the relevant facilities. So if it's storing offsite, transportation to the depot. If it's going to a licensed tip, then it's transportation to the tip off site, as well as the processes after that. And again, the boundaries are very important here to understand where to start and stop with regards to carbon estimation. So in terms of the scheme, let's summarize 2 different options. The first option being procuring granite from China, maintaining the granite for 40 years and disposing through recycling. And the second option being procuring granite from Spain with an increased price, maintaining the granite for 40 years and disposing through recycling. And as you can see here, the total monetary cost of procuring granite from Spain is higher than that from China, because we're setting the variable here of the cost of procuring granite from Spain being 5% greater. However, the total carbon of procuring granite from Spain is much lower because of the transportation carbon incurred, and therefore the total carbon cost is lower, and the overall cost of procuring granite from Spain is lower than that from China. So in this case, you can make the decision to then procure granite from Spain, and in this case, the decision is to minimize the total cost, and in this case, it's the monetary cost of procuring the granite as well as the carbon cost. But there are many ways that decisions can be made, many metrics that you can minimize or maximize, and this is just one simple variable considered. So many different variables can be considered when we create these options, and by undertaking this task, it's very useful for benchmarking and helps decision making with in terms of carbon reduction and carbon offsetting. So moving on to a more realistic case study that we undertook for South Gloucestershire. In this case, we evaluated the whole life carbon and made proposed decisions for 2 public realm schemes. The first one being the Emerson's Green Road Public Realm Scheme, and the second one being the Wraxall Road Public Realm Scheme. So for Emerson's Green Road, we evaluated the whole life carbon of the scheme to be 1,300 tons and the total carbon cost to be £220,000. And by whole life, I'm talking about a 60-year time horizon here. So the 60 years will be very relevant in terms of maintenance. The left figure breaks down the carbon of each series, and each series in this case categorizes the different materials and the different activities. So anything to do with earthworks will be in series 600, anything to do with site clearance will be series 200. And within the left figure here, each bar is broken down into the carbon emission factors. So this includes the embodied carbon of the materials or product, the carbon emissions of transportation, the carbon emissions through construction, and the carbon of disposal. And in this case, the most carbon intensive series are series 700 and 1100. And this is to do with paving, it's to do with concretes, it's to do with asphalt. And it makes sense within the highways industry that these are the most carbon intensive series. And the right figure breaks down the components of the material embodied carbon and shows that the most carbon intensive materials are asphalts and concretes. Now for Wraxall Road, we did the same evaluation and we evaluated the total carbon of the scheme to be 4,100 tons and the total carbon cost to be £720,000. Now, in this case, the most carbon intensive series are series 700 and 1200. And the right figure shows that the most carbon intensive materials are asphalts and plastics. In this case, there's a lot of paint thermoplastics involved. And this is where more complex decisions can be made. So now that we understand in the life of these schemes where the most carbon is concentrated, we can target where to reduce the carbon. And in this case, because for both schemes, the most carbon intensive factors are the product or material embodied carbon, we looked at replacing or substituting the most carbon intensive materials with their environmentally friendly alternatives. So this includes asphalts. So we looked at normal asphalts versus warm mix asphalts. For concretes, we looked at normal concretes versus 50% GGBS cement replaced concretes. And for steels, we looked at their recycled counterparts. And the effects can be seen very clearly here, how much carbon can be reduced by looking at environmentally friendly alternatives. And to put this into numbers, by using these materials with these schemes, overall, we estimated a total reduction of 700 tons of carbon for the Wraxall Road Public Realm Scheme and 300 tons for the Emerson's Green Road Public Realm Scheme. And again, by calculating this then helps us to make further decisions with carbon offsetting. So for South Gloucestershire, and I'm sure for most local authorities, there are separate teams that are in charge of looking at carbon offsetting. But for the project, they wanted us to just give them a quick understanding of what this evaluation means in terms of carbon offsetting and what needs to be done to offset the carbon after the carbon reduction. So we explored two different ways, the first one being planting schemes within South Gloucestershire, and the second being purchasing carbon credits. With regards to the planting schemes, we looked at 4 different schemes, and we used the carbon sequestration tool from the Woodland Carbon Code to calculate the area required by each planting scheme to offset the residual whole life carbon. for the Wraxall Road and Emerson's Green Road public realm schemes. And for Wraxall Road, this is approximately 15 hectares of their planting schemes. And for Emerson's Green Road, this is approximately 4.5 hectares. Again, this is just rough numbers for the highways team to understand, but at the end of the day, they have a separate team to deal with carbon offsetting. The second option with regards to carbon offsetting is purchasing carbon credits. Currently, the UK companies are paying between £7 per tonne to £20 per tonne of carbon to be offset. So we worked out that the to offset the whole life carbon of Wraxall Road will cost approximately £20,000 to £70,000, and for Emerson's Green Road, that will be £7,000 to £20,000. Now, we also include examples from other global projects that sell carbon credits. For example, solar power project in India, Kenya biogas program, or a reforestation program in Nicaragua. And we find that generally this is within the bounds of what UK companies would pay. But again, this is treating the problem as if any organization were to offset this amount of carbon. And this brings me to the end of my presentation. Thank you for listening. I hope this presentation gave a brief idea of the different decisions that can be made through estimating life cycle carbon of highway works. And I will be happy to answer any questions in the Q&A. Thank you very much.
Thanks very much, Teddy, and thanks for giving to the time. Yes, please, if you stay on, we'll have questions at the end. May I just now ask Brian Kent to talk about reducing carbon with recycled roads. Thank you, Brian.
Morning, everyone. My name is Brian Kent. I'm a National Technical Director for Tarmac, and I'd like to talk to you today about asphalt innovation and the part it can play in sustainability. So we're all aware of global warming now. The UK has declared net zero by 2050. Scotland, we can't beat you at rugby, we can't beat you at football, so we're going to beat you to the target, 2045 for us. And the Welsh, yes, they set their own target too, but we're all rowing the same way. So what I want to talk to you about today is, yes, we want to reduce the carbon footprint, and that's a key driver. However, we can also reduce public disruption and reduce costs in certain cases at the same time, making it a win-win-win situation. Teddy referred earlier there to durability, expected life impact, which is interesting because sustainability is a word that can be used in many different ways and has different meanings for people. But actually, if we can improve durability and actually turn the road that lasts 20 years into one that lasts 40 years, you can effectively almost reduce half that carbon footprint of that road. That's quite a simple way. Material selection is also very, very important. We've got to select the right material for the right job. If we don't, we'll continue to see situations like this, and we see them every day in the UK network, and it's simply down in the majority of cases to selecting the wrong material for the wrong application. It's about horses for courses. Now, if you look at that jockeying inside there, I'm pretty sure at the moment, at that split moment, he was thinking he probably picked the wrong horse for that course. Suppliers have been working now for decades. They work with universities, they work with additive suppliers, bitumen suppliers, to try and produce additives that produce materials to tackle challenging environments and challenging situations. There's now a huge range of options out there for you. What do you want? A racing circuit asphalt, fuel resistant asphalts, longer lasting asphalts, airfield asphalts, industrial asphalts, they're all there, but you have to select them. The biggest no-brainer for me is something called warm mix asphalt that hopefully most of you are familiar with, but if not, I'm going to cover just now anyway. And it's a very quick way to reduce your carbon footprint and also save money at the same time. If you look at that slide there on the right-hand side, 150 degrees to 200 degrees is typical hot mix materials here in the UK. What I want to talk to you about is a silver section in there, 100 degrees to 150 degrees. Here's a short film I'll let you have a look at. One of 3 films produced for the MPA to start promoting warm mix asphalt about 3 years ago, pre-COVID. And I found these films really interesting in terms of the stats that threw up. I didn't know traffic jam, standing traffic, led to 4 times greater emissions. That the output using warm mix asphalt can reduce by 12%. That monetary savings, Highways England, who are working in large projects, are between 8 to 10%. And you can actually reopen roads to traffic 90 minutes earlier. Facts here, but also very attractive. Save time, save money, reduce emissions. It really is a case of why wouldn't you? So moving on, here's another film just to bring warm mix asphalt to life for you. So this is a film initially of a squad laying hot mix and warm mix in the same day. Same supply plant, same thickness, same squad. You know, you'd rather be standing behind. Of course, the one on the right-hand side. Left-hand side, visibility issues, health and safety issues from tissue hot mix. Here's another example of benefit. So the previous one was on a cold day. This is a hot day. The squad, hard hats, heavy boots, sun in them, heat from us, 190 degrees rising up. Not a pleasant word. We're now moving on to warm mix asphalt, as you can see through there. Black, shiny, typical asphalt, laid with the same pavement, rolled with the same rollers, no additional for the workforce to consider, just inputs. In the course, during the Highways England trial, this is a PMB surface course where Q workability of an issue type of product. This is outside our Taleongpong quarry down near Bristol. This was laid over 8 years ago now. As you can see, no issues at all. 142 degrees that was laid at. I saw the material myself. It's perfect. And another big advantage is reducing disruption. This is a job in one day and reduce issues you're anticipating in terms of having to do the job over 2 days outside the school and disrupting the school in Derbyshire. So improve productivity, reduce programme durations, early reopening to traffic, lower costs on site, reduce public disruption, health and safety benefits, reduce carbon footprint. What would we not want? It's a complete win-win situation. So why are we not laying a lot more of it? Now, go back to 2013. That was a 3-year project here involving Tarmac and some other partners. And this was funded by the Carbon Trust to look at the benefits of warm mix and lower temperature asphalts in the UK. We thought job done, report published, report number 666, which I wasn't particularly keen on the title. I think someone in TRL had a sense of humour that day, maybe jinxed it, because we then moved on, and I'm looking at 2019 figures now because 2020 was a bit of a washout because of COVID. America, 40% of material they supply warm mix. France, 16% material they supply warm mix. UK, less than 4%. Not leading the world by any means here. So what's going to change now? How are we going to push this forward? Well, drivers have changed. There's now over 350 local authorities declaring climate emergencies. Before COVID, with the school kids striking on Fridays, the last European elections, the Green Party made gains, Extinction Rebellion protests, international strike seems an eternity ago, September 2019, government targets. There really is a focus now on all industries to be reducing their carbon footprint. So the AIA lobbied Parliament in July 2019, and the MPs came on board very quickly and basically said, well, why aren't you doing this? So we put together a report for them. We issued the report throughout the country, and it's a real challenge from the MPs to actually say, you should be doing this, you should be using warm mix asphalt. If you're not, why not? What next? Highways England updated their SHW in 2019, which now includes warm mix asphalt. Tarmac has supplied over 2.5 million tonnes since inception. Local authority adoption is really what the industry is looking for now. We need local authorities or groups of local authorities to say, we will take warm mix as default. The biggest issue we have at the moment, and its impact on the sustainability, is random demand. Some clients want hot, then warm, then hot, then warm. If you run an asphalt plant and you're having to fluctuate between both throughout the day, you're actually impeding productivity. You're increasing the carbon footprint of that plant. We need consistency of demand. And my point at the bottom right left-hand side there is Highways England, fantastic, it's now in specification, but let's get rid of the departure requirement. Let's just use it, default to use. Why? On the right-hand side of the slide, 61,000 tonnes of carbon can be eliminated. That's equivalent to cutting 300 million miles of car journeys, and it's really there and available now. It just needs industry to embrace that change. The one thing I hear a lot about at the moment is RAP. People want more RAP, put more RAP in. That's great, that's sustainable. Well, it is in many regards. However, we have specifications now for decades that have a 10% maximum surface course and a 50% maximum on binder course. Many plants are not hitting those targets. My point is, let's get to those targets, let's get plants hitting the 10%, 50%. There's no need to go to 60, 70, 80% RAP. That's an awful lot of hard bitumen you're putting into your material, and there's got to be concerns over long-term durability. This slide shows on the right-hand side the carbon footprint for 80% RAP, hot mix material, and then left-hand side 50% RAP, which is the current maximum specification using a warm mix, and it shows quite clearly warm mix with 50% has a lower carbon footprint and far less risk than high 80, 90% RAP contents in hot. So let's just get to specification limits. Let's get supplying to them consistently. We really don't need to push the boundaries even further. Single layer asphalts, very briefly. Our specifications go back decades and decades. There was good need in the 70s and 60s to lay binder course, surface course. We were worried about too thick a layer because perhaps we didn't get proper compaction. Material technologies moved on. Additives now give you far greater workability. Paving technologies moved on. Roller technologies moved on. We don't need these barriers of having to lay two layers when one can actually be compacted adequately. Benefits: thick single layers can cut cost, time and disruption. It holds heat retention better, which is fantastic in the winter to make sure you get full compaction and lower voids. Single lift can be more structural than the same in two because you're not worried about delamination or inadequate bond coating between layers. And it also allows us to use more of the readily available larger sizes in the quarries. At the moment, we crush and we recrush to chase 10 mil. Everybody wants 10 mil. That's not sustainable. Every time you crush larger sizes of 10 mil, you're producing dust, which can become wastage. Thicker, single lifts, higher aggregate sizes, more sustainable. A few examples here. This is one of our mixtures. It's based on a 40 mil mixture, laid up to 75 mil thick in one layer, suitable for car parks and low-speed roads. The next one, Ultipave single layer, BB approved, laid up to 50 to 100 millimetre, 20 mil aggregate and 40 mil aggregates, no 10 mil in it whatsoever, reduces recrushing operations and wastage. That's sustainable. Footpath materials. Footpath materials, thick single layers in and out in one day, avoid public disruption, nuisance disruption to old age pensioners, young ladies with prams. You don't want to be walking from one side of the road to the other because you've got bollards and cones and lots of working on the footpaths. They're highly disruptive. Let's do a job in a day, let's not take two. PMBs, durability. Eddie spoke about the impact on life, expected life. Let's put down materials that can cope with underground movement. This is a product that was laid in Warwickshire back in 2012 because Warwickshire has underground movement issues because of clay in the substrate. They generally lay HRA 125 pen to try and avoid the cracking. This was a trial laid to compare a high quality PMB with the HRA, same thickness, same gang, same weather conditions, laid at the same time, and the HRA was cracking within 4 months, such as a challenging environment. And here we are 8 years later, still no cracking in the high PMB material. So it comes back to horses for courses, product selection, durability, all reduces carbon footprint. Moving on from that, let's have a look at using waste materials. We do want to use waste materials. Here's some rubber tyre mountains in Kuwait. Here's the same picture taken from satellite. I mean, that's incredible. You can see these tyre mountains from satellite. Why is that? Well, EU law changed in 2006 and said we can't put waste tyres to landfill. The UK alone produces 40 million tyres that need sent to waste each year. That's not counting Germany, Italy, France, etc. No wonder there are tyre mountains all over the world. We send them to Pakistan, we send them to India, we send them to the Middle East, we send them to China. We've got to stop that. We've got to find a way of using them. We have tried processing shredded granulate tyres underneath sports pitches. We've used as fuel in cement kilns, recycle back to tyres. But despite all that, we're still sending 120,000 tonnes of tyres abroad each year. And that could be subject to change. 2 years ago, the Chinese said they didn't want the plastic anymore. What are we going to do when all these countries say they don't want their tyres anymore? Well, America had a similar problem. 2 billion tyres in the US a few years ago, and they've now 90% gone thanks to more effective recycling. They've actually started, well, they did start putting back in the 90s, rubber into asphalt. They use either pre-blended bitumen or a dry mix process. Over 3 million tonnes of dry mix process laid in America. They found the rubber mechanically restricts crack propagation and provides some low-grade PMB flexibility benefits. Now, this isn't replacing the binder. This isn't becoming part of the binder. It's part of the dry mix process. It's behaving as a flexible aggregate within the matrix. That's what we're adopting in the UK because we don't have the facilities to shear rubber into the bitumen. So we're using the dry mix process. We started looking at it in 2011, and our designs are based on a fine mill tyre rubber. There's a picture of it there. So 0.5 millimetre roughly, and that sits within the matrix. At only 0.6% rubber content, that's still a tyre in every tonne of asphalt. Depending on layer thickness, that's up to 500 tyres on a kilometre road. We can really make big inroads into our disposal issue of car tyres. We started back in 2011. That site's performing well. 2020. We then did further trials, slightly different formulation, 2013. That's performing well, 2020. And then Coventry really started to take off in 2018. And things have moved on really well. We're now available in SMA type products. It's warm mix only, which you get all the carbon footprint advantages there as well. Utilises a slightly softer binder than 50 pen in recognition of some of the volatiles do get absorbed in the rubber during manufacture and laying. Get all the performance characteristics you would get from a 50 pen SMA. Your carbon footprint's lower. Completed a job earlier this year in Leicestershire, 5,500 tonnes. So hats off to Leicestershire for embracing innovation and actually going ahead and laying this. Interest is growing, but it does require plant modification, and therefore it comes back to the client again. The client has to show the interest and the commitment to allow the suppliers to invest to help us be more sustainable. Here's a quote from a senior engineer in Coventry, which I'll just let you read. And a quote from the Secretary General of the Tyre Recovery Association. And we moved on very quickly. Ultipavar. This is a product that Highways England asked us to increase the rubber content, to look at putting even more rubber in it to make it more sustainable, but to try and actually achieve the low-grade PMB properties. They're looking to achieve a middle market option where you can have both in terms of performance and cost, an option between straight run and full PMB. And it is now BB approved. It became BB approved in April this year and is now available for supply with that guarantee. And that's just another quote from the group leader of Highways England. So, finally from me, sustainability. Many ways of achieving sustainability. Effective design. Get your design right in the first place. Pick the correct material. Quality workmanship. You can supply the best product in the world If the contractor doesn't lay it properly, or he lays it in horrendous weather conditions, it's not going to perform as well. Seasonal planning. Why do we lay very thin layers in winter time? Lay them in the summer, go for the thicker lift single layer materials in the winter. Better heat retention, better compaction. Recycling for advantage. Be careful what you put into asphalt. It's not a bin and not a trash vault for anything. Some recycled materials will work, some will not. Reduce wastage. If we achieve all that, reduce wastage, high performance, durability, value for money, sustainability. And my last comment to you is, I bet you've all got a wheelie bin. I don't know what colour it will be. I bet at home you're very good and you put your cardboard in the right bin and your glass in the right bin and your plastic in the right bin. You can have a far greater impact at work than you can have at home. Because at work, by specifying the right materials, by heeding guidance, by embracing innovation, you can make a huge difference to sustainability, far more than you can make at home. But keep filling those bins properly. Thank you. That completes my presentation.
Thanks very much, Brian, for making the convincing case for use of warm asphalt and modified asphalt. If I can ask Mike and Teddy to join us by putting on their cameras. We'll just go through a few questions that delegates have put up. If I may just go, I think the first one is from Mike. Mike, if you've had a chance to examine the different assessment frameworks contained in the World Road Association reports, are there any that really stand out as better than the others?
Thanks for that question. It's a very good question, and without wanting to appear partisan, I have to say from what I have seen, I think as far as carbon accounting is concerned, the UK Highways England model aspect is one of the better ones, insofar as it does cover the majority of life cycle stages and reuse and recycling. So in terms of, I mean, there are many other models as shown in the presentation. Not all of these cover the in-use stage of the pavement and certainly the end-of-life part of the pavement. That said, some of the other models also evaluate the other environmental impact indicators. So things like SEV in France look at resource use, acidification potential, and resource depletion, that kind of thing. As in terms of models, as Brian stated, I can only agree that the key thing in environmental impact assessment is to look at the life cycle, the whole life, and durability is absolutely key in that. So in fact, only looking at the product stage of a road pavement is a rather short-sighted way to do it. You would never polymer modify if you wanted to only reduce the product carbon footprint. But we polymer modify because it extends the life of the material. So using tools like Aspect, we can evaluate one project with another. Of course, the greatest area of uncertainty in this is, of course, the fact that pavements tend, hopefully, to last a long time, and therefore predicting the service life is an area of uncertainty. But if we use something like Aspect, we can compare different options and look and at least estimate the pavement life cycle of these materials. One of the things which in all of the models relates to what I said during the presentation, that we don't just build a road because we want to have a road. We build roads for the traffic to use. And the traffic fuel consumption is by far the biggest energy use in the life cycle of a road. And of course, the pavement surface has a big impact on that. If we have rough, cracked uneven pavements, the fuel consumption of the vehicles will go up. So that is missing from a lot of the models that we use. And it would be helpful, I think, to pavement engineers to know at which point to intervene. When should you invest more carbon in to get the bigger bang for the buck in terms of reduced rolling resistance and also traffic safety. And I'm not aware of any models at the moment which take that into account. Although I know that the Danish Road Directorate is looking at models which take into account other environmental impact factors such as noise and rolling resistance and the impact of the road pavement on that. And finally, Brian made an excellent point about, well, should we be maximizing reclaimed asphalt or not? Transportation of raw materials is quite important and has a big impact. So if you're shipping large quantities of heavy stuff, then this is where we need models like the ones that Teddy talked about to take into account the impact of transportation of large quantities of heavy stuff over long distances. So just to answer the question, I think Aspect is a good model for carbon. It doesn't take into account several other important environmental impact factors, but it is useful in terms of looking at life cycle, and that's what we've got to focus on, the overall life cycle.
Thank you, Mike. I've got a second question, which is probably very much covered by you, but if you or Teddy want to add anything to that, are there any UK carbon assessment tools for highway construction, operation, and maintenance that properly cover whole life cycle cost emissions? If you could keep any answer to less than a minute, that would be helpful because we have lots of questions now to go through.
Apologies, Parvis. I'm not sure if I answered. What was the question?
Basically, are there any UK carbon assessment tools for highways construction, operation, and maintenance that properly cover whole life cycle costs and emissions?
I'm not so sure about this. I know there are many tools, as Micah listed out, and his diagram shows which tools covers which modules within the whole life considerations. For us, we try to cover as many as is realistic and as the data provides. But I think the key here is really to be very transparent about what is covered and what isn't covered, and to create almost a framework that allows modularity, allows for these further considerations to be added on to the analysis. But to answer the question, I'm not sure. I think this is a very new space, so there are many tools out there publicly available.
Okay, thank you for that. Teddy, I think the next question is for you as well. In terms of offsetting carbon emissions, why are investments in overseas offsetting schemes often discussed? We generate the emission in UK, so why don't we offset them in the UK?
There are programs to offset in the UK. The examples that I went through were just examples of global projects. I think there is obviously a very clear benefit of offsetting in the UK. One of which being the extra social value gained by doing that in the UK. And there are many projects, but currently one of the main organizations that certify these offsetting programs, the Woodland Carbon Code, states that there are not that many projects that have the carbon credits certified by them. Now, it goes into the whole process of how do you certify carbon credits, and that requires a long period of time. And because it's just starting, most of the credits are pending, so it's for the future. It's not been completely certified yet. So I think it's because it's very new, but there are many projects starting in the UK.
Thanks for that, Terry. Next question is for Brian, and it's a question which I have as well. Brian, is that what are the barriers to local authorities moving to warm mix as the standard material?
None. I would say none now. There's not an asphalt plant in the UK that can't make ore mix materials now. You either modify your plant to allow you to add an additive as required, or you buy a pre-blended bitumen from the bitumen supplier. So if your suppliers know there is consistency of demand, there is no barrier to local authority getting a hot mix. Other than you can't have it in hot rolled asphalt with pre-coated chippings, because we need the extra heat in the hot roll to bring the binder and the pre-coats back to life. Every other product can be delivered in warm mix.
Okay, and then thanks for that. And then there's a follow-up to that: is what evidence is there that warm mix asphalts provide the long-term durability of conventional asphalts? I believe the slow take-up of warm mix in the UK may be due to this.
Yeah, when you think about warm mix asphalt, what do you want from an asphalt? If you want whatever product you ask for, you can have in a warm mix. So if you want 50 pen, you have 50 pen. If you want 125 pen, you have 125 pen. No one's cutting bitumen contents on this. It's the same bitumen content. It's the same aggregates. It's the same filler contents. It's the same grading targets. You have to achieve the same in situ voids requirements on site. There's absolutely nothing different other than the temps you're supplying and compacted that. So why is there any reason to think that it's going to be any less durable?
Okay, thank you, Brian. The next question is yours as well from Trevor Johnson. Is by what proportion might rubber modified asphalts contribute to airborne particles already generated by vehicles' tire wear, and how can their combined effects on health be reduced to safe levels?
Yeah, I think there's two different things here. If you think of the 40 million tyres a year that fall below the legal tread limit in the UK, that's tyres going from 8 mil tread to less than 1.6 mil. That is a hell of a lot of rubber already on our roads. What we're doing with the fine milled rubber asphalt is we're encapsulating it within the asphalt, within the bitumen. It's behaving as a very small piece of aggregate. Therefore, it is not free to cause any contamination. And at the end of life, it will be recycled with the asphalt as normal.
Thank you. And then the last question, Brian, is yours as well. Is there a specification which guides the scheme design for a particular site? Would you recommend taking cores at every location to judge what treatment or treatments to use and how deep to plane? I
think in an ideal world, that would be fantastic, but let's face it, practically speaking, you're not going to go on core every site. You don't have the time. It costs a lot of money. What I think you should be doing as a client is engaging with your supplier as early as possible. The suppliers are happy nowadays to come to site and look and actually give good advice based on their experiences and within other boundaries, within other councils, other parts of the UK, and actually early supplier involvement, I think, can be more effective. Certainly a lot cheaper than going and coding every site.
That's great. Thank you very much for answering those questions. Thank you again to Mike, Teddy, and Brian for the presentations you've done. We shall now have a break, and we'll get together at 11:45 for the next presentation. Thank you.
Thank you.
Okay, everyone, welcome back to the second part of this morning's seminar. I understand some people are experiencing problems with accessing the seminar at the moment. We'll carry on, and I'm sure organizers will tell us if there are any changes or whether we need to do anything. So I'd like to invite Victoria Walsh from the Devon Council now to talk about the road to CO2 net zero in highways construction. Victoria, over to you.
Hello everyone. Hi, thank you for having me. Victoria, I work within Devon County Council, and as just said, I'm going to be chatting to you about reduce carbon emissions specifically within highway construction works. So a little bit about myself while my screen's loading up. 19 years experience in the high maintenance sector, and I've been privileged to work on this project with some highly skilled engineers within Devon County Council, which has been great. I'm sure they won't mind me saying that what we aren't are carbon experts. And I say this purposefully because although you might need to take advice from experts, and I will explain to you in Devon on our journey, it shouldn't be a reason to not start the journey. You can make progress. And what we found are the two main components to help with that is to have the backing of your organisation and to have the enthusiasm within the team that's working on the project. So hopefully you can all see my screen. I'm going to be speaking to you today about our carbon reduction journey. What I would say is it is something that we are still on the journey with. So we're by no means completed. Okay, and it's been an agile journey and we've been learning as we go. And the other thing I would say is that we're by no means saying we've got it 100% right, because we are learning as we go. So I'd be really, really keen to hear any peer review feedback that anybody might have following this presentation, because my feeling is the more we share good practice, the more we all learn together. So, step one, what's the first thing we did? Well, the first thing we did on our journey is we put some terms of reference together. Now, this isn't unique to carbon reduction. This is general good project management principles. But it was really, really important that we had a clear objective as to where we wanted to get to. And you can see on the screen that this evolved into investigating, considering and embedding new ways of working to reduce carbon emissions. And we wanted to do that when we were designing and commissioning construction works. And you'll note that it is for both new works and highway maintenance operations. So quite a wide remit there. Another factor that emerged during our initial conversations, it's really quite a key component in our project to Devon, is that we would take our carbon emission calculations as what we're calling a whole life costing of CO2 approach. So this is really about the cradle to grave approach. And the reason we have gone down that route is because we want to be able to fully reflect everything in that carbon footprint. We want to know fully what are the emissions that we're outputting for this particular construction activity. And the more that we can include in that data set and that calculation, the better. We also reached an early decision to calculate our baselines on a set volume basis. So for example, what does a metre square of resurfacing look like? What does a metre square of surface dressing look like to us? Okay, and the reason behind that is once we understand them on a set volume basis, we can build it up into future schemes for estimates. Whilst writing our terms of reference, there were a few key areas of focus that came out for us, and I just wanted to run them through with you today. You can see them obviously on the screen. The first one was around the asset management approach. So right at the start, when we are looking at our road network condition and we are selecting potential sites for maintenance schemes, our feeling is that if we take stock and account of carbon through the treatment selection right at the start, we will see gains throughout the entire process. And this is really about fundamentally changing our asset management approach. The next step is how do we design out carbon? And this is a term that I've been saying more and more to my colleagues in Devon County. I want to see you designing out carbon. We have a job as engineers to do. We have a solution to a problem on the network to get to. But actually, as well as designing that solution, how do we design out carbon? And I will talk to you about the potential tools that we're going to give our designers to empower them to be able to do it on a scheme by scheme basis. The last one is really a golden thread. So cultural change. We had a bit of discussion about this in the first session about actually this is a massive change, isn't it? It's a massive behavioural change for individuals, for organisations, for the industry. So how do we manage that change and bring our teams along on the journey with us? So we are carbon literate, I think is a term that we've had chucked around a little bit. I like that term. And how do we balance that traditional thinking? So thinking again about our asset management approach, where we would focus on the costs, we would focus on what is the technical solution to keep our network maintained. But actually, up on a par with that needs to be, what does the carbon outlook for what I'm proposing to do look like? So we have a carbon orientated outlook right through the entire process. The next step we looked at was putting a governance process in place. Now, I'm not going to bore you by talking you through our governance process. I put this slide in just to point out a bit of learning that we've had on the journey, that without a governance process, you'll probably lack two main factors, and that will be good communication flow and a decision-making platform. We found in having those, that's been really, really valuable to move things forward. So we've got the where we want to get to. We've got a governance process in place to help us get there. We then had to scratch our heads and say, how are we going to do it? And that's where this model that you are seeing hopefully on the screen at the moment came out. So this is our business process model. And as I said at the start, we're still going through the journey of embedding this. So I'll just talk you through the different stages. Stage one, the setting of baselines. We've had a little bit of talk in some of the other presentations about this, particularly in the first session. To us, this is a really fundamental stage, because how can you possibly measure reduction of carbon if you don't know where you're going from? Where is your platform? So we have been going through on an activity by activity basis to understand what is our current output of carbon, so we can use that to help produce in the future. Now, that task in itself, anybody that's on the call from a local authority, it's quite daunting because it's quite a large piece of work to do, and it can be difficult to know where to start. So within Devon, we scratched our heads for a little bit over this, and we decided we were going to baseline per activity. So are we doing a patch? Are we doing a resurfacing site? Are we repairing a pothole? Are we doing drainage works? And we would overlay those activities against some values that were important to us. And you can see on the screen, we've got material. Is it high in carbon? Waste, is there a lot of waste? Are we using lots of fuel? We've spoken a bit about sustainability of works today, which is really great. So how long do we expect that repair to last? And how often do we actually do it? And we put together a really simple red, amber, green RAG rating against them. And what that enabled us to do is to come out with a priority list of the hotspots, if you like, which activities have a higher carbon impact, and therefore which ones are more beneficial to start with the baselining. Some items that we learned from doing that was it's really, really important to engage with your contractors. I can't stress that enough. We have been really, really lucky in Devon that we've had some really great contractors who have really helped us on this journey. There is an element there of trying to break down that commercial barrier wall. I think we spoke about that in some of the sessions as well, and working together, because there's a benefit in both directions to sharing data, having an open relationship, and moving this forward. We have used historical data, and we've tried not to overcomplicate. So there have been times when we've been baselining where we haven't been able to obtain live site data for something. If we've had to use assumptions, our view is at this initial stage where you're starting the journey, actually, do you know what, that's okay if it moves us forward, as long as we understand those assumptions and we weight our decisions based on the level of assumptions. Other thing is, you may need experts, and we've been privileged to be working with Exeter University on these baseline calculations. So we have our baseline. The next thing we do is we would share them with relevant stakeholders. So these are people like our asset management teams who are setting our programs, our designers who are commissioning schemes, our contractor, anybody really that has the ability to reduce down carbon levels, have an influence on that. We then have looked at developing with, again, Exeter University, a carbon impact tool. So this is still in progress. We're running some trials at the moment with some of our great contractors to get some feedback. But this is about, as I said earlier, empowering individuals who are responsible for commissioning works to give them the opportunity to be able to make adjustments and design out carbon. Now, I was really keen to hear earlier about Teddy's presentation about taking the whole life costing of carbon emissions. And that's what we're intending to do with this designer tool that we're developing. So if we're expecting a 40-year life cycle out of a road, I don't want to know what that one patch repair looks like in carbon. I want to understand what does it look like if I do a patch repair and I need subsequent visits. So what's the overall impact of the carbon? Because that helps us make the right decision. You know, actually, should we be looking at resurfacing? It's going to be more costly. The initial work will have more carbon output, but over the 40-year cycle, we might be making savings. It also enables our designers to make decisions on the location of sourcing materials. Can we source them more locally? Can we make adjustments to materials? And how does that look against the offset of how far those materials have to be transported? So, and it aims to include all aspects of the job. So we've commissioned the works, we've given it to our contractor who's kindly gone and done the works on site, hopefully aiding us in that journey by reducing down the carbon as well with some of their opportunities. Doesn't end there for us. So what we would then like to do, and we've just entered into some trials with this just throughout the summer, is we would like to take live site data. So we'd be asking, working with our contractors, to try and take live site data back. And what that enables us to do is to measure the actual carbon output of a job against targets and see, hopefully, that we are getting reductions. So we can start to put our targets out, we can start to profile where we want to be and check that using live site data that we're hitting those targets and we're heading in the right direction on that journey. So what this model in effect allows us to do is have an estimated emissions at the design stage and have an actual emissions. So we can start to see from the baselines what reductions, what improvements have we made? And if we're not making improvements, why is that? It also enables us to look at hotspots of carbon. So are we focusing our attention on the right areas to be able to get the biggest gain? So we got to the top of the cycle. What do we do now? Are we done? Well, no, of course we're not. So the idea is we will continue around that cycle and we will go round and round and round the cycle until we get to a point that we physically can't reduce carbon anymore. We've done all of the gains and all of the things that are available to us on the market, which will be ever emerging, and we feel we need to start to consider offset. What I didn't say at the start of the presentation is that Devon County have raised a climate emergency, and we're looking to get to net zero with all of our emissions within Devon County Council by 2030. So when you look at that and you look at the work that has to be done within construction works, it's actually not that long, is it? So just a little bit from me on the returns of live site data. So we've been working again with Exeter University and we have developed up a template that complements the calculation for our baseline. So that whole life cost of carbon calculation that they've designed for us. But what we are really conscious of is that there isn't a standard for this in the industry. And that makes it, I think, probably slightly more complex. What we don't want to do is pull our contractors from pillar to post because all the clients are asking for slightly different variations of the same. And there is a massive variation on how you can pull together a carbon calculation. So we are going down this journey where we are testing out some live data returns with contractors, but we are also really, really conscious of the fact that it needs to be as simple and effective as possible, because everybody benefits from that, and that any standardization that we can make across the industry is in everybody's benefit. So again, as I said at the start, really keen on any feedback anybody has on that. Ultimately, where we'd like to get to, and this is a really long-term goal, is that we have almost a price list for carbon as we do a price list for materials. But that would be, down the line, something to work towards. So that's our journey. That's where we are. We're still very much in the embedment stage of that model, and it is a lot of work, and it is a long journey. You're not going to get there overnight. We're certainly not getting there overnight, but we are seeing improvements, and we are seeing some great enthusiasm from some of our contractors, which is absolutely brilliant. So what we are going to do now is we're going to open up some polls. I believe that they're in the conversation section, the conference section on the tab. And that's just about getting some of that feedback from you guys that I spoke about at the start, really keen to share best practice and understand other people's journeys as well. So that's it from me. Thank you very much for listening to me, and I hope it was useful.
Thanks very much, Victoria. I'm now going to invite Ollie Beach to come in and talk about low carbon highways maintenance. Thank you.
Ollie, you're currently on mute.
If you're not able to unmute yourself, no, we can come back to you. So may I suggest we move on to the next presentation, and Ollie will come back to you in about 10 minutes, if you may. So I'd like to invite Lucia to talk about Graphene Trials. Lucia, are you there? Right, thank you. So you're on mute too. Are you able to unmute yourself? You're not. I ask organizers to see what they can do. Okay, there seems to be an issue. I didn't have any problem unmuting myself. So,
Sorry to interrupt, Parvis. Lucia, could you just please refresh the page, please?
Thank you. Mark, is it worth moving on to the next presenter, or?
The next presenter is not with us at the moment.
Okay.
If Paul Aldridge is here, then Paul could speak now.
Hi, can you hear me now?
Yes, we can, Lucia. Over to you. Thank you.
Okay, I'll start sharing my presentation. Sorry about that. Can everyone see the presentation on the screen?
Yet, not listening.
Can you please let me know when?
It's still not on our screens.
Okay. What about now?
Still cannot see your presentation.
Oh, sorry.
Lucia, I will share my screen for you.
Okay, thank you very much.
Thank you, Mark.
Okay, sorry about these technical problems. My name is Lucia De Ferraris, and I work for Milestone Infrastructure within the Oxfordshire Highways contract. Milestone Infrastructure is a new company that was born after the sale of the Skanska Infrastructure Services to the M Group. The subject of the presentation is the trial we did in 2019 in Oxfordshire of a graphene enhanced modifier, which is called GPAVE. Can I please have next slide, please? So this is the site where we did the trial, is in West Oxfordshire, near Witney, and the name of the road is Main Road in Cambridge. And you can see from the photo the condition of the pavement before we did the trial. Next slide, please. So as I said, main road in Cambridge is a single carriageway, category 7 within the Oxfordshire local maintenance. It's a collector road and a bus route subjected to a design traffic of 3.2 million standard axles. The trial happened on the 4th November 2019 and was managed obviously by the Oxfordshire County Council and Skanska at the time, in collaboration with Aggregate Industries and Iterchimica, which is the Italian company who supplied the graphene additive. The trial was supported by laboratory preliminary testing that were run in parallel within the Aggregate Industries lab in Derbyshire, and also in Italy at the Iterchimica lab in Lombardy. Both trials, both laboratory investigation used UK aggregates and bituminous binders. The trials is supported by 2 years monitoring plan. Can you please share the other slide, please? The GPAVE, the graphene enhanced modifier, is made by selected recycled plastic, which you can see in the picture on the right side of the slide. Iterchimica additives and graphene. Next slide, please. Then in this slide, you can see the pictures taken from the day when the trial was carried out on Main Road, and particularly in the middle of the slide, the picture in the middle shows the GPAVE pellets, and everything was pretty much normal compared to a standard material. Can you please go to the next slide? This is the layout of the trial. The depth and type of treatment was an 150 millimeter inlay. The surface course was a low void SMA 4060 and the binder course an AC20 4060, which are basically the standard material supplied by Aggregate Industries in the Oxfordshire contract, and both of them were to both of them a 5% of GPAVE was added. The trial had one lane of Main Road was laid with standard material only, and the second lane had 4 sections. Again, one section with the standard material, both in surface course and binder course. The second section with the G-pave material in surface course and binder course. The third section had the G-pave in the binder course, but not in the surface course. And the fourth section had the G-pave in the surface course, but not in the binder course. Next slide, please. The trial was supported by a pre-construction GPR and FWD. We repeat the FWD probably in November 2021. We should have done an intermediate FWD testing at year 1. That means November 2020, but we skip this step because due to the lockdown, the pavement didn't have enough traffic to make just a good assessment of the performance. But having said that, with the post-construction testing results and the as well as the preliminary pavement preliminary analysis in the lab were encouraging and supported a theoretical pavement performance assessment, which we hope to refine once the monitoring plan will be fully implemented. Next slide, please. In terms of results, we could observe an increment of 25% in the stiffness value for the G-pave additive materials. That was both for surface course and binder course. And that was at all frequencies. Next slide. The best result was related to the resistance to the permanent deformation, which was up 40% for the G-pave materials, and then you can see we had an average of 3.6 millimeter root depth for the SMA control, which not went down to 1.9 millimeter for the SMA additivated with G-pave, and we had the 4.3 millimeters for the binder course standard, and the 2.6 millimeter for the binder course with G-pave. Next slide. We also did some fatigue testing. The fatigue, I have to say, was slightly better for the G-pave material, but all in all comparable, which, considering the addition of plastic, is per se already good results. Next slide. This slide shows the outcome of the pavement analysis, and we get a 70% increase in life for the full depth addition of G-pave, both in surface course and binder course, a 50% increase in theoretical design life if the G-pave is added in the binder course only, and only marginal 20% if the G-pave is added in the service course only. These are theoretical results at the moment, and as I said, they will be revised once the monitoring plan will be fully implemented. Next slide. So the trial generated quite a lot of attention from both national and international press. And as I said, I mean, the early test result indicate that G-pave is a material that can provide superior performance, particularly if it's used on both surface course and binder base course. And therefore, the material has the potential to provide a significantly improved full life cost. As I said, we wanted to carry out more further investigation, but they were postponed due to the pandemic situation. And we do hope to do a further trial with this graphene enhanced modifier in Oxfordshire, also because Oxfordshire has a culture of living labs, so they are very supportive of any innovation. And this time we will look for a site with heavier traffic condition, and we'll compare this graphene enhanced modified mixture with polymer modified material this time. So this is very briefly what happened with this trial in Oxfordshire, and thanks for listening, and happy to take any question.
Thanks very much, Lucia. And if I can ask you to remain on the panel, we'll take the
Yes, I will.
at the end. Thank you. And I'll just invite anyone to add their questions in the Q&A column. Now we have got with us Oliver, who hopefully can unmute himself. And over to you, Oliver. Thank you.
Great. Thank you, Parvis. Hopefully coming across okay now.
You are.
Great. Sorry about that. So yeah, good morning, everyone. My name's Ollie Beach. I'm the environmental manager at Milestone Infrastructure. So I work for the same organisation as Wiltshire. We deliver a range of highways maintenance and street lighting services to local authority clients across the UK. We're also involved in delivering larger infrastructure improvement projects as well. So in the southwest itself, we're currently the highways term maintenance contractor in Devon, Somerset and North Somerset. And we also do street lighting maintenance in Gloucestershire as well, where we were initially appointed in 2014 to do the LED upgrades. So within the next sort of 10 minutes or so, I'm hoping to give you a quick sort of whistle-stop tour of how Milestone Infrastructure as a contractor are approaching the need to deliver low carbon highways maintenance solutions, not only to meet our own sort of carbon neutrality targets, but to also support our local authority clients in achieving theirs as well. I'll briefly touch on how we've undertaken work to establish our own carbon baseline for our own operations and monitor our emissions before highlighting some of the sort of key carbon reduction initiatives we're implementing across the business. And then I'll just quickly touch on some of the key challenges and opportunities we've experienced from the perspective of a sort of contractor working in these highway services. So our initial priority in terms of the carbon agenda has been to sort of establish an accurate carbon baseline for our operations and capture data in a way that allows us to monitor, review and scrutinise those emissions data across various timescales, so be that quarterly, annually or in year-on-year timescales as well. So for transparency, on the slide you'll see there the table that breaks down our 2019 carbon baseline into scope 1, 2 and 3 categories in accordance with the OnCorb protocol. So this helps our clients in their own reporting requirements as well, especially where there's only like a certain proportion of our emissions that fall sort of in scope for their carbon neutrality targets. It just provides that clarity. It also allows us to then track our own progress against the various carbon reduction projections. As a majority of our highways maintenance services are obviously delivered through quite an extensive supply chain, including that scope 3 data, which makes up 90% of our emissions, was really, really important in terms of understanding where our true carbon hotspots were in that baseline data. Despite the obvious sort of challenges that presents in getting that data in the first place and coming up with that estimate. So yeah, as Milestone Infrastructure, our target's ambitious as well, net zero by 2045, but including those scope 3 emissions as well. We recently produced our first annual carbon report, which highlighted an 8% reduction in total carbon emissions since that baseline moving into year 1, and 11% reduction in carbon intensity. We have included that carbon intensity figure in our reporting, bearing in mind the impact sort of variations in delivery might have on that sort of total number, and yeah, which might not necessarily be reflective of how we're actually progressing in terms of delivering our activities in a less sort of carbon intensive way. You may be thinking that the reductions might have just been driven sort of purely by COVID. We did see some reductions in staff travel and office depot occupancy, which we need to consider in the longer term. Now we've adapted to that sort of way of working and trying to do that a little bit more. But that was counterbalanced by the need for extra vehicles and things like that to adhere with social distancing requirements. The most significant reductions that we have seen were driven by a number of initiatives, which I'll sort of touch on now. And yeah, as part of that initial exercise to get our carbon emissions data in order, we were sort of beginning to look at how we could present that in a sort of meaningful and user-friendly format, which led to these various dashboards that we produced for our scope 1, 2, and 3 data. We've utilised Power BI as our preferred tool for visualising and scrutinising this, working closely with our digital team to pull these together. We can present these interactive dashboards to the client. You can click on various icons within these dashboards, apply various filters to drill down into the data and adapt the visuals to look at what you want to investigate. And yeah, makes it particularly useful in identifying those hotspots relating to work categories, material types, certain supply chain partners, where our sort of carbon reduction efforts should then be focused. Yeah, from this we've had main focus areas. Those are on the slide there in terms of plant and fleet, materials, and then obviously design underpinning all our carbon reduction sort of actions in accordance with PAS 2080. And yeah, to just go on now onto some of the initiatives that we've looked at under each of these focus areas in this sort of year one that's driven that reduction. So yeah, 35% of our baseline carbon emissions come under that plant and fleet section used by Milestone and our supply chain. We've obviously got a goal to move away from combustion engines at the earliest opportunity. However, there are obviously challenges there in terms of availability of technology for the types of vehicles or plant we use, whether the models are available, and obviously sometimes we're locked into longer term lease agreements as well. So challenges to overcome. Something that's been a particular sort of quick win solution on that is hydro-treated vegetable oil fuel, HVO fuel, as an excellent interim solution where that technology isn't yet available, or we're not otherwise able to utilise it. This is something that we've used on our Cambridgeshire Highways contract over a 1-year period and plan to roll out more widely across the business. It's effectively a green diesel made 100% from waste cooking oils, which is certified and auditable through our supplier. It delivers up to a 90% reduction in carbon, so big saving there. And then there are other air quality benefits as well, which is sort of demonstrated by that photo in the bottom left-hand corner in terms of a 30% reduction in NOx emissions and potentially up to 85% reduction in particulate matter as well. It doesn't require any sort of bulk storage tank modifications, vehicle plant modifications, making it a quick win. And it's been approved by a range of sort of original equipment manufacturers that are used widely across the sector. At the moment, HVO is slightly more expensive, but the rates that we have are fixed for a 24-month period, whereas the standard fuel prices are a lot more unstable and rising rapidly, meaning that gap's closing. And if the current sort of trend continues, we expect that HVO will become a cheaper option in the near future. We've also undertook extensive trials of electric plant equipment, including mini diggers, road sweepers, telehandlers, mutes, hand tools. And we've also been, as part of this, looking at trying and testing zero carbon temporary site setups for the larger schemes and projects that we deliver. So utilising hydrogen, solar powered welfare facilities, tower lights, hybrid models, etc. And yeah, trying to basically demonstrate that they do work and they do deliver costing carbon savings at the same time. We do have our own sort of plant and fleet division within the wider M Group as well, who have purchased a number of the solar pods that you can see on the screen there in the bottom right hand corner. And these have provided sort of up to 95% of the compound's power requirements for the schemes that we have used them on in Oxfordshire recently, for example. And other benefits there are associated with obviously reducing noise, spillage risks, refueling requirements, and even commercial risks if we've got things like the red diesel tax subsidy that's potentially going to be removed next year. Design is that second focus area, in recognition again that it underpins a lot of carbon reduction, especially when it comes to materials, which forms such a significant part of our overall carbon baseline, which I'll touch on very briefly in the next slide. And yeah, it includes our own designers that are working on contracts, doing design and build, as well as supporting our client designers as well. So yeah, following the principles of PAS 2080, we've tried to embed that sort of carbon management within the decision making throughout the whole life cycle of the project. And considering that obviously there's the biggest opportunities for carbon reduction at that early stage of the contract, we've been focused on getting that carbon assessment done as early as possible and understanding those problem areas, so we can then target our carbon reduction efforts accordingly. That work has been done in-house using our own environment team to support our clients, and we're starting to talk to some of them as well about exploring the PAS 2080 accreditation as well, where we deliver these design and build services. Again, using Power BI as a tool to scrutinise the data and drill down into some of those hotspots around particular material types and what key activities are contributing to that. Recognising the importance of early supply chain engagement as well in that. We have engaged our supply chain designers, client, and even regulators in collaborative carbon reduction workshops across some of our contracts, and engage sort of suppliers in lunch and learn sessions so we can familiarise our designers with low carbon products and allow technical queries to be asked. And then, yeah, third and final sort of focus area is materials, 64% of our baseline. So yeah, really important area. One of the focuses there has been trying to embed this circular economy approach, where we're taking our depots, effectively turning them into recycling hubs by turning waste products into recycled materials that we can reuse on the network. So that's ranged from recycled aggregates to turning hazardous tar-bound asphalt into cold recycled bound materials, delivering 50% reductions in carbon, and also trials to turn even gully waste into usable products using innovative drying and screening methods. Again, just reiterating some of the other presentations, it's been really key to get that early sort of designer engagement and client engagement and looking at some of the alternative products. So yeah, warm mix asphalt there, which we know we've spoken about, has been a key focus for us. And we laid just over 14,000 tonnes of that last year. So just to bring on to my final slide, just to summarise really the sort of term maintenance contractor perspective on this as a bit of a case study. I thought it'd be useful to show some of the sort of key challenges and opportunities within that table there. We haven't got time to go through them all today.
1 minute to wrap up, Ollie, thank you.
Yeah, no problem. But yeah, just to say that we have definitely realised significant operational and cost benefits associated with trying to drive these carbon reductions across the business, especially when we've sort of considered things from a whole life perspective. And yeah, just think our response to obviously COVID-19, the way that we've embedded new ways of working there to obviously continue delivering these essential highways maintenance services under significant constraints is hopefully something we can replicate in delivering the sort of ambitious zero carbon agenda as well. So yeah, thank you for listening. Really grateful for the opportunity to present today, and hope you found it informative. Thank you.
Brilliant. Thank you very much, Oliver, for that and overcoming the technical issues. I'd like to go straight to Chris Ball, who is going to talk about the digital world. Chris, over to you. Thank you.
Sorry, apparently it won't let me screen share. Mark, I don't know if my presentation to hand.
Great.
There we go. Right. Hi everyone. Today I'll be walking you through going digital in highways operational processes and how it's not just a paper removal exercise. As some may or may not know, Reflow is a digital workflow management system used primarily across highways and construction. So many organisations working across UK highways already have some level of digital transformation in place within their IT operations. Even if that's just specific software tools. However, with so many fragmented offerings out there and very little time to research them all, many companies never even realize the true breadth of the full digital step change they could make, not just to their environmental footprint, but across all areas of operations. Three key areas that are part of the transformation are the process that they follow, automations that they can include, and then the analytics they can receive off the back of it. With digital transformation, highways leaders can understand that while the future is uncertain, what happened yesterday and the day before can tell you a great deal about what could happen tomorrow. So you can continually best working practices and processes. Making your process digital is one of the most effective ways to reduce carbon. Job management information, schedules, and subsequent changes to become instant and, aside from the energy required to power your phone and computer, completely carbon free. When your paper forms eventually make it back to the office, someone usually gets the task of transferring the information over to a digital system, but people often don't see this for the duplication of work that it is. If the on-site teams tapped in their form responses at the point of use, it's available to the office digitally and immediately. It also stops anything getting lost in translation from typos, jargon, or missed sections that inevitably lead to the form getting bounced back to the operatives. Fortunately, existing clients of Reflow and other systems are a great crowd and not only well on course to get 1 million digital forms submitted this year, they're sparing their colleagues from taking part in the 2021 Paperwork Ping Pong Championships. This year has been an incredibly busy year for our clients, and they've already saved at least 50 trees just by bringing their forms online, with almost 500,000 documents completed digitally in 6 months alone. Establishing workflows that can have automation introduced to them greatly helps with consistency and efficiency in business operations, as well as reducing errors. Automating repetitive tasks or processes will also free employees up to spend their efforts on things that matter and save you time and money. It also eliminates so many unnecessary journeys to and from sites and offices to manage the information. The forms in Reflow are an integral part of our system. They can play a significant part in the success of our clients and their efficiency. The way they are formatted follows the traditional paper fields that people are familiar with, but they have conditional logic built in, which means that if more information is required, the form will guide users to complete it, or alternatively, if certain sections are irrelevant to the form at hand, they disappear and save the operative time and effort. We looked at one of our largest surfacing clients to see what their most submitted forms in 2020 were, and the results showed a resounding win for submitting defect checks. By regularly checking and approving their kit. As you'll know, any assets that are out of action are costing you money. With each day lost to carry out maintenance and servicing means you can't use it for productive, sustainable revenue generating activities. If a small problem was missed until it made the asset unusable, the downtime can take weeks instead of days, especially if you're held up waiting for specialist parts or labor. As digital solutions bring a higher frequency of insights and data at a faster rate, it provides a more effective means for managers in the highway sector to be able to identify the important. Giving staff the ability to input data directly into the system at the point of use means you now have immediate insights to action and make changes to avoid future inefficiencies. With digital analytics, you can immediately manage and report for health and safety scenarios, as well as use predictive analytics to see things like which vehicles are most likely to require replacement. Sometimes capturing an image on the job might seem inconsequential and a waste of your time, but if you need to refer back to something that happened a while ago, or worse still, has since been covered over with a new layer of asphalt, earth, or cladding, then that photo can become suddenly invaluable. Today, with different working environments and even more remote working, being able to provide visual data to other members of the team so they don't need to be there in person, giving them access and accuracy of information that can't be matched with written information only. Plus, it's always helpful to be able to compare and contrast the before and after photos to show clients the quality of the job you've done. So what needs to come from people taking on this digital transformation? Well, it's not about installing a new tech platform and witnessing a revolution. You need to start little fires everywhere to build the momentum for change. It's then that you can really make a significant change in the way your business can work and get a genuinely transformative change from a new technology. Be brave and determined like our others that have made jump. Ultimately, successful digital transformation requires long-term thinking, but we recommend highways companies break up progress into smaller steps rather than one grand transformation. It's going to come down to a senior business leader, to senior business leaders, not just the IT department taking strategic responsibility. This isn't a siloed divisional change. It's a challenge for the whole business. Crucially, if it's not the priority of a chief executive, MD or owner, there's a much higher risk of failure. And as we've seen, successful digital transformation is just as much about company culture as implementing our new technology. Thanks.
Thanks very much, Chris, for your presentation. I'd now like to go to our last presenter, Paul Aldridge. Paul, over to you. Thank you.
Hello, everybody. So I'm Paul Aldridge, and I am Sustainability Director for WJ Group. We lay road markings and provide safety surfacing solutions across the UK. Lots of work down here in the southwest, and we also manufacture our materials, which is one we're to talk to you about. I often start with these presentations with this look at the carbon stripes. I love it as an image. It was developed by a guy called Professor Ed Hawkins, who's a climate scientist at the National Centre for Atmospheric Science in Reading University. And it just shows the changing climate from 1850 over here right the way through to the present day as a visual representation using the colour of the deeper, richer reds coming through to where we are now. And it's quite a shock.
Paul, sorry to interrupt you. Your slides are not on screen.
Oh, right, okay. That's a pain.
Would you like me to screen share for you?
Yeah, if you could. Okay. Are they up now?
They're on the screen now.
Okay, that's fine. So, where does that leave us? So what was our issue as a company? And basically, we're burning too much stuff. It's quite simple. Carbon comes from combustion. And as an organisation, we use about 3 million litres of diesel a year, which gives us scope 1 and 2 carbon footprint of circa 9,000 tonnes. And we also manufacture 10,000 tonnes of hot applied road marking material, thermoplastic road marking materials. And this was one of the areas we need to look at. So if I could have the next slide, please, Mark. What we realised, or what we knew in the background, that we could make big savings around the materials that we use with the embodied carbon in that material. So what we did is we set up a lifecycle analysis. It's a very simple process. So you look at the raw materials, where they come from. Ours is a global supply chain. So we look at our aggregates that we use in the material are basically calcium carbonates. They come from a quarry at a place called Coin in Spain. It's near Malaga. Or sometimes we use some other materials which come from Italy, but basically it's a white stone. We also use The binder materials, resinous materials, and we'll come on to those in a minute. So we looked at those and where we came from. We ascribed a value to all of those. Then we look at transport to our manufacturing plants in the UK. We have two. We have one in Bradford and one in Milton Keynes. So we worked out the footprint of that transport, and then we work on the production footprint. So how much energy goes into production, and what we can do around waste. Waste in our particular products is really low. We're less than 1%. And just by going through this process, we learn that by doing simple things like filtering out the dust from the atmosphere, not only made it safer for our people who are working in the plants, but we could actually put it back into the product as a useful component. So that gave us a footprint for our finished goods. And what we did with that was we got the whole life cycle assessment accredited to ISO 14067 and past 2050 by Lucidian, because I think one of the important things with the whole idea of understanding footprint is that we have to have a place that we all work for. So we went for this certification of our materials to internationally known standards. So if you flick onto the next one, please, Mark. One of the really significant things we found in this whole process was the difference between the binder systems that we used. One was based on a hydrocarbon resin, and one was based on a biogenic resin. So looking at this, you can make exactly the same material with the two resins. But if you use a hydrocarbon resin, we came up with a carbon footprint of 2.74 tons CO2e per ton. It produces durable material, it's quite good quality, meets the current specification, but you do get this high environmental impact. And then we looked at the biogenic substitute, and this gave us a massive saving. It's essentially a straight switch. So a ton of our material produced with a biogenic binder system suddenly gives you a footprint of 0.52 tons CO2e per ton. And also, it's a slightly better material, so it has a slightly greater durability, has a greater quality. One of the things it does is holds the reflective elements within the material really well. Still meets the current specifications, but it does have this low environmental impact. So that actually gave us a reduction in footprint of around 81%, which is quite remarkable. And can you flick onto the next slide, please, Mark? That gave us a saving of 22,000 tons CO2e a year, which is quite enormous. If you think back to what I was saying earlier about our operational footprint, with even buying 3 million litres of diesel a year, that only gives us a 9,000 tons scope 1 and 2. So it's a really, really significant drop, this. And as we move forward, and we're all looking at various things we do, it gives us a social value return using the TOMS calculator for our organisation of over £2 million a year. And of course, being a biogenic material, it brings our sort of natural and recycled content in our materials up to around 90% in some of our products. Once again, this is sort of pushing to where we need to be going forward as an industry. It's one of the things that always strikes me about this whole thing is I've been in the industry for a really long time now, and we've been slow to change. We all know that sort of things like the energy industry has dropped their footprint by 60% on 1990 levels. At the moment in highways and construction, we're about 4%. And things like this, we're only a very, very small part of the highways industry. But if organisations like ours can find solutions like this, it helps bring the carbon cost of what we're doing down, the carbon intensity. Could I have the next slide, please, Mark? So beyond that, we have to start looking about what we're going to do as well with our footprint from our delivery, our scope 1 and 2. Some of the things here that we're doing, we are also looking at biofuels. One of the things that always concerned me is the sort of where they come from. And I think, you know, as long as we can buy that recognized stuff, that's what we need to do. But another thing we're doing in the background, because we realize that the difference that we're making with our materials is good, but we've still got this footprint around our delivery. And as we wait for technology to improve and more electric and potentially hydrogen fuel cell vehicles come into line, what we took the step to do was we're planting this year and next year, we're planting a forest, or about up in Glenshee in Scotland, about 500,000 trees. And one of the things here we can do is we are restoring biodiversity, which is something as a road marking contractor we never realised we'd be able to do, and creating future materials for the future. So the forest is a split. There's some commercial forestry in it and natural broadleaf woodland. And we know that as industry, we're going to need products going forward. So the commercial side of it, we don't make any apologies for. We will need those materials going forward. And as I've said, our resins, the biogenic binders that we use, are based around resins from trees. So essentially the resins that we use are a byproduct from the paper industry. And the trees, the paper industry wants fiber to make its product, and all the sap and the residue that's left over also is what we use to produce our resins. It's not new technology, this, but one of the things we did by going through and measuring it and verifying what we did was it demonstrated the importance of doing this. And at the same time, it gives us an opportunity to work on restoring biodiversity and putting something back into the communities that we serve as an industry. So it's really important for us that. And have the last slide, please, Mark.
Paul, 1 minute to wrap up, please.
Okay, right, that's fine. So what can we do as an industry? We've been doing this morning, and it's about understanding our impacts, gearing up on emissions reduction efforts, educate, collaborate, knowledge share, what we're doing here, toughen our net zero commitments, require life cycle assessments for our materials, innovate low carbon alternative circular services and products, and be more compliant, transparent, and just be open to learning. So yeah, this is the part we're trying to play in it, and I think as a responsible industry, this is all we got to do. And that's it from me. Thank you. So thanks for listening, and any questions?
Thanks very much, Paul. Wise words to finish on, and it's all about learning and sharing information. If I may now move on to the questions which have been posted by delegates. If I may also ask the speakers to put their cameras on. I'll try to divert the questions best I can. There are 2 questions, unfortunately, for Teddy and Brian, both of whom have left since the first session. So perhaps organizers can see that those questions are sent to them for an answer. So for this session, I'll move, the first one is for Lucia. Thank you for your presentation. Why did you decide to replace the surface course and binder course rather than just the surface? And why did you choose SMA rather than HRA? Let's see it. Are you having problem unmuting yourself? You are. All right. We'll move on to the next question until this is back. The next question is, given the parallels between carbon assessment tools and CDM principles, is a similar regulatory system needed to embed carbon reduction within the highways industry? I don't know whether Victoria or Oliver want to respond to that.
Can you hear me okay? Palace?
Yeah,
great.
Yeah.
Yeah, so just from our perspective, I'd encourage it as much as possible. We're doing it across the business, trying to encourage it with our clients, just knowing the benefit that early assessment can have in terms of driving that carbon reduction and understanding those hotspots at an early stage. So yeah, just from our perspective, we're trying to do it anyway, but I definitely encourage something like that, I think, to really embed it.
Thank you. Victoria, did you want to add?
Yeah, I'd add to that slightly that I completely agree with what we'd like. Got that same ethos of carbon as we do for CDM reduction job without following the same ethos and culture set with for carbon reduction as well. Okay,
thank you. Thanks for that. I'd like to go back to the previous question to Lucia. Lucia, would you like me to repeat it?
Yes, yes, please. If you can repeat, that would be a lot better.
Why did you decide to replace the surface course and binder course rather than just the surface? And why did you choose SMA rather than HRA?
Well, first of all, I mean, we wanted to understand the benefit of the graphene, generally speaking, not for the whole performance of the pavement. So, and therefore, because we wanted to assess if there was an increase in design life, obviously being the binder course, the structural layer, more than the surface course is, obviously. So our first, I mean, goal was to modify the binder course first and the surface course. But as I said, we within the trial, we actually assessed the benefit of the addition of the graphene addition in the surface course only compared to the standard material, binder course only, and binder course and surface course, and the vast majority of the benefits came from the full depth addition or just in the binder course, as I said, because they are the structural element of the pavement. The surface course, there is this marginal 20% increase, which is, for me, can be just read as an increase in service life rather than structural life. But I mean, it needs to be included in a whole life cost exercise and see if it's worth not spending the money for an addition of graphene.
Okay.
Only in the surface course.
Yeah. Okay.
And the reason why we chose the SMA is that is basically our standard material in Oxfordshire. So we wanted to really assess the increase in performance compared to what we use the most. So the HRA, we tend to use HRA only with polymer modified materials, and particularly where we have issues with skid resistance. But we found that the low void SMA is ticking the box also for the durability, because it's a dense material and therefore is the one we use the most.
Okay, thank you. And probably there's a scope for another research project with HRA for somebody else.
Oh, definitely.
So the next question from Paul Davis, this may be for you, Lucia, but if others want to respond. So the question is, there are clear carbon benefits in adding materials to mixes. However, are we confident or evaluating the legacy issues of disposing of recycling of these mixed materials at the end of life. Lucia, have you done that in yours?
You are probably talking about the use of plastic in roads. Well, when we decided to progress with the GPAVE trial, we were assured by Iterchimica, who are the supplier of the additive, that they did all the testing related to the to this material being environmentally compatible. So we were assured that no residual plastic were found could be found within the mixes. And I have to say, based on the testing we have done, there are no undissolved plastic in the material. So from our point of view, I mean, if the additive as a whole works, I don't think this issue with the plastic is a real one, because you only have an issue if the plastic remains undissolved within the materials, and that was not the case.
Okay, thank you. Thanks for that answer, Lucia. The next question, I think, is for Oliver from Mark Luker on behalf of Charles. How much more expensive is HVO, and how readily available is it in Devon?
Very good question. It depends. It very much depends on a number of factors in terms of which supplier you're using, quantities that you're ordering at a given time, whether you've got availability of tanks, or whether you need to order those tanks in, obviously, to house that fuel. I guess what I would say is, again, taking into account all those factors, I think last time we looked, it was in the region of within like 5p a litre difference a range, but I just think we need to look at what alternative what other measures would need to be put in place to deliver that same carbon reduction. And again, if these standard fuel prices continue on their trend, it's very likely that it will become the cheaper option as well in the near future. It's difficult to answer exactly what that price difference is, but there's sorts of things to think about.
Okay, thank you. Thanks, Oliver. And on to the last question. Really, I think it's for Brian. Kent would have answered this, but if any of you wish to answer this, how far are we from having cold lay as a realistic alternative to hot or warm mix asphalt? Is this a sensible aspiration for the industry? Has anybody here got any views on cold lay asphalt?
What can I say? I mean, the cold lay, I think we should sooner or later become braver and start using cold laid materials, because I mean, it's true that the performance are not in a way with comparable thicknesses are not similar to the one of the hot mix material or even the warm mix material, but obviously the cold laid materials, they have a lot more benefits in terms environmental benefits, starting from carbon, and as my colleague Oliver said, I mean, we in Oxfordshire we reuse quite a lot of the tar-bound planings, which is and the cold laid materials are the only approved way to reuse these planings without breaking an environmental agency law. So we are using them. Obviously, if the performance are slightly inferior to the hot mix material, then this can be taken into account during the design stage. So because obviously we at least in Oxfordshire we carry out analytical design, so we based our design on performance.
Thank you.
Yeah, such as the stiffness. Yeah.
A brave attempt to answer that. Thank you. So there's hope in use of cold lay in future. We're coming up towards 1 o'clock. We've covered all the questions put by the delegates. It just remains for me to, first of all, thank Victoria, Lucia, Oliver, Chris, and Paul for sharing their thoughts with us. Thank you very much for your great presentations. Event wouldn't be possible without the support from our sponsor, Atkins, and other supporters, WDM, Pay by Phone, and Southwest Highway. So thank you to all of them. Please do visit the exhibitors' booths, which will remain open till 9 p.m. Today. And don't forget to come to the next event on 22nd of June. The link is shared. And all that remains to say is thank you all to all the speakers, all the delegates, and hopefully see you in a couple of weeks' time. All the very best. Thank you.
Thank you very much.